Hello and welcome. Today we're going to uncover the single physical law that connects the roar of a powerful engine to the gentle whisper of a coastal breeze.
It seems like a pretty weird pairing, right? I mean, a complex piece of machinery and a weather pattern. What could they possibly share? Well, the answer reveals one of the most fundamental, most powerful rules in the entire universe. And that connection? It's the first law of thermodynamics. At its heart, it's a really simple but incredibly powerful idea. You can't just create energy out of thin air, and you can't destroy it either. All you can do is change its form. And this one rule governs absolutely everything, from the fusion that powers stars millions of light years away to the chemical reactions happening inside your own body right now. It's kind of like a universal, unbreakable accounting principle for all the energy in the cosmos.
So probably the easiest way to wrap your head around this law is to think of it like a simple budget, but for energy. And in this budget, there are really only three accounts we need to keep an eye on: heat, internal energy, and work. First up, we've got Q, which stands for heat. This is any energy you add into a system, like using a flame to heat up a container of gas. You can think of this as the income flowing into your energy budget. Next is U, and that represents the system's internal energy. This is all the energy that's already contained inside the system, bouncing around in its particles. It's basically the balance in your bank account, the energy you have stored away. And finally, we have W, for work. This is the energy that the system uses to go and affect its surroundings, like a gas expanding to push a piston. This is your spending. It's the energy that leaves the system to actually get something done. So here's the crucial part, this beautiful little equation. The heat you add to the system, delta Q, has to go somewhere, right? It either increases the system's internal energy, that's your savings, delta U, or it's used to do work, that's your spending, W. Your income equals the change in your savings plus your spending. Not one single bit of energy ever gets lost. It's all accounted for.
Okay, so theory's great, but now let's see this whole energy budget in action inside one of the most important machines we've ever built, the internal combustion engine.
The engine in most gasoline cars runs on what we call a four-stroke cycle. And each one of these four steps, intake, compression, power, and exhaust, is a perfect real-world example of our energy budget being put to work. And what's really cool is that each stroke lines up with a specific kind of thermodynamic process, where one variable is held constant. So let's just walk through it. During the intake stroke, the pressure stays the same. We call that an isobaric process. Then, during compression, that piston moves so fast that no heat can get in or out, making it adiabatic. And for that tiny, explosive moment of combustion, the volume inside the cylinder doesn't really change, which is an isochoric process. So you see, the math changes a little bit at each step, but the first law's main principle, that all energy is accounted for, that always holds true. But for all of this amazing, elegant physics at play, here's a number that might kind of shock you. In most car engines, only about 20% of the chemical energy that's locked inside the fuel actually gets turned into the mechanical work that moves your car forward. So, where does the other 80% go? Does it just vanish? Nope. The first law tells us it's not destroyed. It's just transformed, mostly into waste heat that gets dumped into the air through your radiator and your exhaust pipe. The energy budget always balances out. It's just not always very efficient. Okay, so now let's zoom out. We're going to go from the inside of a hot engine to the wide open planet. Because this same law doesn't just run our machines. It also powers these massive global systems, like the daily rhythm of coastal breezes. This whole thing is driven by one very simple fact. Land has a lower specific heat capacity than water. Now, in simple terms, that just means it takes a lot less energy to change the land's temperature. So, on a sunny day, the land gets hot way faster than the sea right next to it.
And this daily temperature difference creates a gigantic, natural heat engine. During the day, the land gets hot, the air above it rises, and that creates a low pressure zone. So cooler, denser air from over the sea rushes in to fill that space. That's your sea breeze. Then at night, the whole thing reverses. The land cools down faster, creating high pressure, so the air flows from the land out toward the warmer sea. That's a land breeze. It's literally the first law of thermodynamics written across the sky.
So think about that for a second. From the intense heat and pressure inside an engine's cylinder to the gentle breeze that cools an entire coastline, the exact same fundamental rule is running the show. Energy is always accounted for. And that's really the big takeaway. This law is our lens for understanding, well, pretty much everything. It's the rule book we use to track energy as it flows through the universe, changing form and making everything happen along the way. It's a pretty powerful idea to just sit with for a moment. From the electricity that's powering the screen you're looking at to the metabolism that's powering your own thoughts. Every single process is just one more link in this ancient, unbroken chain of energy transformation.